In the previous video, we built our very first LED circuit. That was a huge step forward, but it was always on. Today we're going to make it smaller and more interactive by adding a switch, so you can turn it on and off just like a real lamp. But before we drop it into the circuit, let's explore different types of switches, understand exactly how they work, and choose the one that is absolutely perfect for our project. Right now we have something like this. The only way to turn this off is to remove battery. That's not very practical. A switch is simply a way to connect or disconnect the circuit with one easy move. The simplest switch is called SPSD, single pole, single throw. It's just one connection that can be either open or closed. Closed means current flow. Open means it doesn't. It's most basic on and off switch. Then we have SPDT, single pole double throw. It still has one input, but it can connect to two different outputs. For example, it could select between a red and a green LED with a single toggle. Next is DPDT, double pole double throw. Think of it as two SPDT switches linked together. This is really useful for things like reversing the direction of DC motor. By flipping both connections at the same time, you reverse the polarity going to the motor, so it spins in the opposite direction. This is called an H-bridge, and a DPDT switch can do it in one move. So, with a DPDT switch, you can make a little car go forward or backward just by flipping the toggle. Switches also have markings that tell you how they behave. This means it stays on or off until you flip it. This means it chooses between two outputs. This is momentary, normally open. It only connects while you press it. This is momentary, normally closed. It's normally connected, but pressing it disconnects the circuit. Switches also have current rating. A tiny switch usually can handle a few milliamps, perfect for an LED. But if you try to power a motor or something heavier, it may spark or fail. When you're buying a switch, always check its voltage and current rating. It may not fail immediately if you go over the limit, but it will wear out much faster and its contacts may get damaged over time. Staying within the rating means your switch will last much longer. So, now you know the basic types of switches, what their markings mean, and which one is safe for our LED projects. Let's improve the circuit we built before by adding the switch. This is the switch I will use. Now we will remove battery. You always want to disconnect power if you changing something in your circuit to make sure you will not break any part. First we will move our resistor. We will rotate it and place like this, and now we will connect a switch with resistor and power rail plus, like this. Now we can connect our battery, and nothing happened. Let's flip the switch. Still nothing happened. What did... Oh, I missed the hole. It should be that one. Yeah, now it's working. And that's it. Now the LED only lights when the switch is on. And switch doesn't do anything magical, it just completes or breaks the circuit. Now you know how different switches work. You know how to read their markings, you understand why their rating matter, and you know exactly how to wire one into your circuit. But what if you really want to use a tiny switch? Because it's small, sleek, and fits perfectly into your design, yet it can't handle the current you need? Don't worry, there is a solution. In the next video, I will show you how even the tiniest, weakest switch can control a much bigger load with the help of transistor or a MOSFET.